Alright guys, today we are talking about Chapter 2, Section 2, which is all about solving inequalities using addition and subtraction. Now, with what we were doing yesterday, we already had our inequalities isolated and by themselves. That's not going to be the case moving forward. And we know, just like we did last chapter, you're going to have more complex equations to solve. Same thing is going to apply here for inequalities. You're going to have some inequalities that aren't already simplified, and we're going to have to get that inequality by itself before you are ready to move on and give the solution. So the way that we'll do this, we have two different properties, and this is just kind of a fancy way of explaining the same thing we did in Chapter 1, where we know in an equation, if we added the same thing on both sides of my equation, that equation held true. With a inequality, we still have those same properties. Now, this is a very fancy way of saying this. So our addition property of inequality says that if I know that A is bigger than B, and I add something to both sides of my inequality, if I add the same something on both sides, A plus C is still going to be greater than B plus C, because A was originally bigger than B. So if I add the same thing on both sides, those numbers are still correct in terms of my inequality. And the same thing applies if A was smaller than B. A plus C is still going to be smaller than B plus C. And the same thing for our subtraction. If I subtract the same thing off of both sides of my inequality, the truth of my inequality stays the same. It does not change. So if A was originally bigger than B, if I took A and subtracted a C, that's still going to be bigger than if I subtracted C from B. And the other direction also holds. If A was smaller than B, A minus C is still going to be smaller than B minus C. So what these definitions just tell us, or what they give us, is just the ability to solve our inequalities using the same tools, the same methods that we did for our equations. So if we take a look at number 1, we're trying to solve these inequalities by addition, and then we're going to graph our solution. So for this one, we're starting with x minus 4 is less than or equal to 6. And before I can graph my inequality, I have to have my x by itself. So in this case, if I'm trying to get my x by itself, right now I'm subtracting 4 from it. So if I was going to do the inverse operation of that, I would add 4 on both sides. That's going to cancel out on the left side, just like it did in my equation. X is still on the left, less than or equal to 6 plus 4 is 10. So that's my solution. And if I was going to graph that, just like we did in 2.1, I'm just going to make sure I've got 10, 11, 12, 9, 8. I need 5 values on my number line. My circle happens at 10, since that's the boundary. It is an or equal to, so it's going to be a closed circle at 10. And in this case, less than or equal to 10 means the left side of my graph is going to be shaded. Or like we had the shortcut I had taught you guys, my inequality points this direction, so that's the direction my graph should be shaded. Okay, let's try another one. Number 2. Now I've got y minus 10 is less than 14. So if I go through this one again, I see that I'm subtracting 10 from my y value. So if I want to do the opposite of that, I would add 10 on both sides. Those cancel out. Y is greater than 24. So I got my number line. I don't really care where it happens. 24, 25, 26, 23, 22. It's going to be an open circle at 24 since it was just greater than. And since it's greater than, I'm shading to the right. So that would be my solution. Y is greater than 24, and that's what my inequality graph looks like. If I solve using subtraction, I know that's going to be because I'm starting with something that is being added. Y plus 7 is greater than or equal to 12. So I'm going to subtract 7 from both sides to get my y by itself. My inequality does not change here. 12 minus 7 is 5. So I go to my graph, 5, 4, 3, 6, 7. It's going to be a closed circle at 5 because it's or equal to. I've got that extra little line underneath my absolute value, sorry, my inequality symbol. And here y is greater than or equal to 5, so I should be shading the right side, greater than. Last one here of our regulars, and then we'll do a couple of word problems. For this one, w plus 4 is less than or equal to negative 5. So again, I'm going to subtract 4 to move my term over. W is less than or equal to negative 5 minus 4 is negative 9. So when I go to my number line, negative 9, negative 8, negative 7, negative 10, negative 11. Make sure you're careful on those negatives because when you're negative, the bigger the number is, the further away it is from 0, the further left it is. Graphing wise, this is going to be a closed circle at negative 9 because it's or equal to, and w is less than negative 9 or equal to negative 9, so shade it to the left. Okay. We also do have a couple of word problems we're going to take a look at, or some application problems. So in this one, just like we had for our equation word problems, when we deal with these, it's going to be important to read through it once, find your information, and then go back and see, all right, well, what am I asked to find? So in this case, a school bus can safely carry as many as 76 students. If there are 19 students already on the bus, how many more can board the bus? So we see I've got two important numbers here, 76 students and 19 students. So in this case, the scenario that we're modeling is students on a bus versus the capacity of that bus. Those are going to be the two sides of my inequality here. I know that in total, 76 is the maximum number of students that are allowed to be on the bus. So if I'm thinking about it in terms of inequalities, 76 is going to be the biggest number that is possible. So the left side of my graph, or the left side of my inequality, that represents the actual number of students on the bus is going to have to be smaller than that 76. But I also know, because of how this is phrased, as many as 76 students, we're okay with it being exactly 76 students. That would still be perfectly acceptable. So that's going to be the right side of my inequality. The left side is the actual number of students on the bus. So we're going to have to define what the variable is. So in this case, we're trying to figure out how many more students can ride the bus. So maybe we'll just say S for number of students that can still board the bus, plus my 19 that are already on the bus. We know that those two numbers, when I add them together, it has to be less than or equal to 76. So that would be how I set up my inequality. Now if I go through and actually do the subtraction here, I'm going to subtract 19 from both sides. And I get S is less than or equal to 57. So we can have up to 57 more students board the bus. So I can, let's clean that up a little bit. There we go. So we could circle that, and we could also say 57 more students can board the bus. Okay. For the last one, in order to get an A, you need to get more than 200 points on a two-part test. If you scored 109 points on the first part, how many more points do you need? So in this case, like if we thought about in terms of like part 1, part 2 of a test like we did last week, in order to get an A, if you need to score at least you need to score more than, right? That's going to be important, more than 200 points. And you know that 109 is what you got in the first part. Well, your total score is going to be, I don't know, let's just say T for test plus 109 is your total score. We need that to be more than or greater than 200. So that's going to be my inequality that's set up. the second part of my test, plus 109, has to be greater than 200 in order to get an A. So to solve that, we're just going to subtract 109, and we get that we need to score higher than a 91%. Or sorry, a 91 point score. It is not percentages here. So we need 91, more than 91 points. All right, that's all I got for you guys today. Take a look at Google Classroom for the homework. I posted it on there out of the textbook, so you guys can take a look on there and get started on it. As always, if you have any questions, pause this, rewatch it as many times as you need to, and if you're still confused, then reach out and let me know, and I can help you out whenever we have a chance to meet together, whether that be office hours or during class. All right, have a fantastic day, and if I don't see you, have a fantastic weekend.